Hey there, it's Jimmy with Vista Pros Heating and Cooling. Today I am out in beautiful Hereford, Arizona. Look at the view of those mountains. Man, it is awesome. It's overcast today, nice and cool. Great day to be doing a startup. So today we are going to be firing up this Mitsubishi Slim Duct mini split. This system here is installed on this brand new guest house for this customer, and we are going to be firing it up for the first time. So let's get to it. Alright, so start up this Mitsubishi unit. I've got my stuff here, got my hoses, vacuum pump, got my tool bag, pretty much all ready to go. If you haven't done this before, this will be a great video. But basically what we're going to be doing is the first step is to pull a vacuum, and when we pull a vacuum we are essentially pulling all the air and moisture out of the lines to the indoor unit that's inside. This unit here is sealed off by the valves. This unit does hold basically enough refrigerant for the condenser, as well as a certain amount of line set. I believe for mini splits it's 25 feet. Don't quote me on that. I will look at the manufacturer's data before I charge it. But yeah, first thing we need to do, pull a vacuum, get everything out of those lines, get it ready to release that charge. Okay, so first thing we want to do is take off these panels. This is the electrical panel. It's not really necessary to pull a vacuum to take this one off. But I just like to see how everything looks, make sure everything looks nice and clean, looks correct. Okay, it does, which is beautiful. Okay, alright, now we got number 2 panel off, which is great. We'll go ahead and set these to the side. So okay, so when doing a startup, you're going to see on mini splits, we've got 2 flare fittings here. Looks like a 1/4 and maybe 1/2 inch. These are 2 flares. These are 2 valves right here. So let me grab a wrench here and I'll show you. Take off this cap. Oh man, that was tight. Okay, there we go. Okay, what you'll see in here is that basically it takes an Allen key. These valves, when closed down, they will not let refrigerant or anything pass. When they are backed all the way out, it opens this port up, allows refrigerant to go through. This is pretty standard for most systems. One thing I do like very much about the Mitsubishis is that they put a standard 1/4 inch port on here. Makes life so much easier without having a mini split adapter. So first thing I'm going to do here is use my Schrader core remover to take out the Schrader core. If you haven't actually used one of these before, they're really awesome. I always recommend pulling out Schrader cores and pulling a vacuum. It just makes life so much easier. So what we're going to do here is remove this Schrader core. I am under the assumption that this system has pressure in it. We request that all of our installers use nitrogen as the last pressure test for the system. And that basically just leaves the system under pressure. So when we come out, we should find it under pressure. This kind of is a double check on whether we have a leak or not. Something as far as that goes. This unit here doesn't have enough clearance for me to get under it, so let me see if I can find a nice rock here. Okay, got myself a nice rock, and just just going to give myself a little bit of extra clearance. There we go. So now I'm going to tighten this on. Let's go ahead and remove. Oh, we got pressure. Oh, we got a lot of pressure. That's good. Tells us we don't have a leak in the line sets. This has been a couple days, maybe even a week since it was trimmed out. It's the process of installing the equipment and the registers on a new house, if you're not familiar with that. So I'm listening for some clicks. 1, 2. That tells me that the threads have come all the way out. I'll let that come out. Shut this off. And let's see if we got our Schrader core here. There we go. Ooh, got a little bit of damage there, bent. I did feel a little bit when I closed this valve. I think I bent that. I'm gonna go ahead and replace that Schrader core. Okay, there we go. Got our brand new one. Life is good. Now what I'm going to do is go ahead and let out the nitrogen. Alright, so what I just did there is I plugged in my vacuum pump here to the outlet. One thing you notice about mini splits is that they only have one port to work with. Everything from that port beyond is the low side of the system, suction side if you want to call it that. So you don't get two ports to work with like on most other systems. You just get one port. So what I'm going to do here is go ahead and hook this up. It's going to be a little bit difficult, but I think I can manage. I hope. Buddy. Finally get threaded there. Yep, we did. Great. Okay. Now I'm going to go ahead and hook up my hose here to the 3/8 port on my vacuum pump. Okay. Alright, not sure if you can see that. There we go. Okay. So basically I've got Schrader core removed, hose going straight to my vacuum pump. Now what I'm using here is the Blue Vac Pro. Going to be hooking this up. Got an extension. Pretty easy. Just helps keep the gauge clear in tight areas. So I put that on. Okay. I'm going to turn that gauge on. All right. Beautiful. Okay. All right. What I'm going to do is I'm going to go ahead and open my app here. I'm going to connect my gauge. Okay, and we are now charting. Let me go ahead and get you closer. Okay. Alright, so what's really cool about the BlueVac gauge is that it charts a graph for you, lets you know. The way I have this set up is basically we're going to evac. Our evac target is 500 microns or below. Once it gets down to 500 microns, it's going to start a 5-minute timer. We want to have a vacuum under 500 microns for 5 minutes. Then after the 5 minutes, our timer is going to go off, and we are going to isolate the system and start our decay test. Decay test is basically just holding the vacuum in the system without the pump drawing on an active vacuum on the system. And we want to make sure that that vacuum stays under 1,000 microns over the course of 10 minutes. So that's what we're going to be doing here. We find that complies with most manufacturers' recommendations. So that's what I use. So let me go ahead and turn on our pump here. Oh, no power. Okay. I need a breaker. Be right back. There we go. Okay. What are we saying? Calibrate gauge soon. Okay, I will do that. So you can see that we've got our arc coming down here. The deeper the vacuum goes, the longer time it's going to take to pull. Right now we're looking for the green line here, which is our 500 microns. Okay, make sure our ballast is closed. Okay, good. As you can see, our pull down rate is pretty good here. Let's see, we are at still 1,200 per minute, and we're at 640 microns. So let's keep this going here. Okay. All right, we're waiting. As soon as we get under 500, that timer should start going. There you go. So if you're not familiar with the vacuum process, there are several stages. Basically, this stage here is where we start removing moisture, things like that. How we see that is pretty simple. Here's our saturation temperature. What this means is that water will now boil, because we've dropped the pressure so low in the system. Water will now boil at negative 24 degrees Fahrenheit. So being that it is 83 outside, I mean, the water is going to boil inside the system, turn to a vapor, and then the vacuum pump will then be able to remove that vapor. So we're still getting a really good pull down rate on this system. We've been running our vacuum for 3 minutes and 50 seconds. We're down to 260 microns. So we're just going to keep going. We want to let our 5-minute timer expire here. Come on. There we go. So, something I want to say, what's really nice about this BlueVac gauge is it has built-in logic. Not only is the app really nice, but what it does is it compares the decay rate once we start our decay test to the amount of time. So a normal decay test, you would shut it off, wait the 10 minutes, and make sure that it doesn't go above 1,000 microns in 10 minutes. Well, this will actually measure the decay rate and use logic to figure out if it can predict if the decay rate will not rise above 1,000 in 10 minutes. And sometimes it'll give you a pass within 30 seconds. That's really nice, saves you time, and it also gives you a nice little report saying either a pass or a fail. And that's really cool if you want to make sure that you're, like, if you're having issues with leaks and things like that. This is a really good tool to implement to make sure that you know, that you don't have leaks and you don't have issues, and to get a really good vacuum on the system. So as you can see, we're down to 160 microns, 159. We have relatively small line set. Like I said, looks like quarter and half. So we'll just keep running until our timer here hits 0. Okay, 1 minute left and we're down to 150 microns. If you guys prefer the different views, it has that. The log view is pretty good. If you don't like that, you can go to the gauge view if you prefer that, and it'll tell you it's in the finishing vacuum stage, which is really good. It'll kind of give you an idea of where your vacuum is. I prefer the log view, honestly. It gives me a better idea of what's going on, kind of an overview snapshot. So okay, 17 seconds left. It'll also show you the seconds on the gauge. You can run this gauge without the app if you need to, but I always prefer the app. 3, 2, and 1. Okay, gauge is going to beep. Alright, so now what I'm going to do is I'm going to shut this, isolating the system. I turn off my pump, and now I'm going to continue with my decay test. So the pump is not pulling an active vacuum, it's just measuring the vacuum that's in the lines currently right now. And as you can see, we are holding, well, that was quick. Well, it gave us a pass. You can see we're at 228 microns right there. So what I'm going to do is I'm going to go finish and save. I'm going to go to view. So it gives us a nice little how long the vacuum was, did we get a pass or a fail, what the finishing was, all that stuff. So what I like to do is I'm going to hit share. You can send it to MeasureQuick if you use that. I export to PDF, and then I'm going to share again as a copy, and I'm going to send that to my job on Service Titan. Okay? Alright, so now that the file's been uploaded, our vacuum is now finished. So now we can go ahead and release the charge. I always like to start with the opposite port that the gauge is on. For some reason, I think it just helps to reduce oil basically getting into the system. So I'm going to crack it just a little bit, waiting for my gauge to come up here, and then shut it down. Okay, still under a vacuum. Shouldn't be, but it is. Okay, got that open. A little bit of pressure there. Okay, so let me shut my gauge off. Okay, pack that up. now I've got this backed out, just snug it. Okay, same thing here. There we go. Oh yeah, a bunch of refrigerant came out with that. Okay, snug. Doesn't have to be too tight. Don't want to cause any damage. Okay. Now we're going to put these caps back on. I always prefer to snug up these caps. Not as tight as they were originally, but just snug that vibration can't knock them loose or anything like that. Okay. All right. Now that we've got our vacuum basically pulled, go ahead and our refrigerant charge released. Let me go ahead and disconnect this hose. Okay. All right, now we got our hose disconnected. All right, so what I'm going to do here is flip our disconnect here to give this unit power. Okay. I'm hearing some noises going on. That's good. Okay, let me go check the inside here. Okay, now that we're back outside, you can see that we got the system running here, which is what we want. We're going to wait a little bit for that compressor to ramp up. Shouldn't be too long. In the meantime, I'm going to check the data here, make sure we're doing this properly. Make sure we add the right amount of charge to the system. Don't want to overcharge it. All mini splits are critically charged, so what that means is that you can't charge them by superheat or subcooling or anything like that. You have to charge them by weight, and you need to try to get as precise as you possibly can. So let me go ahead and look that up, make sure we're going to get the correct charge, and then we'll charge it. Alright, so I've let the system run for probably about 15 minutes, hooked up my my temperature probes inside, as well as my pressure and temperature probes out here. So I went in, I put the thermostat as far down as it'll go on the cooling, in cooling, as far down as it'll go, and then I made sure that the fan speed was on high. And so what I can tell you is right now we're getting about a 28.8 degree temperature split with about 3 degrees of superheat. Now when it comes to mini splits, you have no idea really what they're doing. They have electronic expansion valves, they've got temperature sensors and all kinds of stuff. They have logic that they run off of. You have no idea what this thing is doing or why it's doing it, so don't try to charge it off of superheat or subcooling or anything like that. Have to do it by weight. I think I just mentioned that. But another thing is when I looked at this, I estimated that the line set is about 10 feet up to the attic. And then in the attic where it goes, if you look through this window here, you can see the mini split is up there in that ceiling. So I would say that it's probably around 25 feet. This unit does come pre-charged with refrigerant for 25 feet. So I'm not going to add any refrigerant at this point. Looking at my temperature split, temperature splits on mini splits is usually between 20 and 30 degrees. I'm at 28.5 right now. So we're looking really good. It's cooling nicely. So I'm actually not going to add any charge. I'm just going to leave it as it is, button it up. Then I'll go through and test the heating mode on it, and make sure that that works. Once I get done testing all modes of operation, I will once I get done testing all modes of operation, I will be done. I'll put the company stickers on it, give it a wipe down, and call this one done. Alright, so I'm just going to show you my button-up process. Nothing major here, but I showed you the start, might as well show you the finish. So let me go ahead and close this down. Got some condensate come off the line. A little bit of oil there. Okay. So here I got a low battery. Alright. I'm going to put the Schrader core back in here. Just like that. Little more height here. There we go. Okay. Open that, push that in. We'll tighten it, and I'm just going to tighten this until it's snug. Do not over tighten these. You can break that little flat piece off of the Schrader core, and then you'll never get it out. All you'll be doing is changing the valve, and that's a lot more work. Okay, there we go. Come on, buddy. Just didn't want to come out of there. Okay, so now that we got our Schrader core back in, let me go ahead and put this cap on. Okay. All right, snug. Okay. Get my rock out. Straight. Looks good. Okay. Oop. There we go. All right. Now we got our top panel on. We go ahead and secure the bottom panel. Okay. All right, now all I have left is to pick up my tools and put the company sticker on it. So, as you see, this thing is running, man. It is really quiet. Okay. Finishing touches here. There we go. Just like that. It's beauty. All right. There you have it.